Rabbits have long been associated with spring and Easter. Rabbits occur in folklore and modern children's stories as characters that evoke sympathy, as these creatures are vulnerable and innocent. They are known for their speed and agility and overloaded cuteness. If we see playful and friendly rabbits jumping up in the air, performing twists and turns, spinning and kicking in the air, engaged in fun and frolic, we feel delight. Our minds become fresh and rejuvenated, and we feel the joy and our tension drains out. One of the greatest thinkers of the 13th century, whose name was Fibonacci, was fascinated by the rabbits in particular, and to be precise, with their breeding speed, and he invoked the rapid breeding ability of rabbits to promote a series he discovered, a sequence he invented. But unfortunately, though he and his series or sequence became enormously famous, the poor rabbits became infamous and earned a bad name, and even a nation is reviled by comparing its people with rabbits. And this is the story for the next few minutes. Fibonacci, the talented Italian mathematician, composed a book in 1202 named Liber Abaci, which was a book of numbers, where he posed a problem or a puzzle which became famous and came to be called the rabbit problem. Before coming to Fibonacci rabbit problem, let us put forward a simpler problem, the problem of finding the rabbit population if their number doubles each month. Suppose on the first day of January next year, you get a gift from your best friend. The gift is a couple of baby rabbits, one male and one female. And you allow them to grow up in an idealized condition. The conditions are: number 1, rabbit population doubles every month. Number 2, rabbits, that is the male and female rabbits you got as a gift, would reproduce or procreate exactly one pair of baby rabbits, of which one is male and the other female, after a span of 1 month. So pair of rabbits generates another pair, and we thus have 2 pairs of rabbits after 1 month. In other words, population doubles each and every month. Number 3, the rabbits we are referring to would not die till our observation or calculation is over. No problem of mortality, that is mortality rate or the death rate is 0. Number 4, the pairs breed only and there is no other inbreeding. We come to the question now. How many rabbits do you have on the first day of the first 5 months? That is, on first day of the months of January, February, March, April and May. And also we have to find the population of rabbits in December and January next year. Let us come to the solution. On the first day of January, there was 1 pair of rabbit, that is 2 rabbits. After 1 month, that is on the first day of February, population doubles so that there are 2 pairs, that is 4 rabbits. After a further period of 1 month, that is on the first day of March, 2 pairs double, and we now have 2 twos are 4 pairs, that is 4 twos are 8 rabbits. On the first day of April, we have 4 twos are 8 pairs, that is 8 twos are 16 rabbits. And on May Day, we are blessed with 8 twos are 16 pairs of rabbits, that is 16 twos are 32 rabbits. We note that 32 is 2 raised to the power 5, and May is the 5th month of the year. So we can guess the formula, and it is simple. The population in a month is 2 to the power that month number. Clearly thus, in December, which is the 12th month of the year, we would be blessed with 2 raised to the power 12, that is 4096 rabbits, which is actually 2048 pairs. This is marked in the red in the right bottom of the following slide. And by the same logic, in January next, which is the 13th month, the rabbit population would be 2 to the power 13, that is 8192 rabbits or 4096 pairs, as marked in the green in the next slide. Such an enormous increase of population or breeding can be modeled using exponential type of function. Hence, such population growth is referred to as exponential growth. After solving the problem of exponential growth of rabbit population, what occurs to our mind is that we should be much more reasonable in dealing with the real problems. How can rabbits reproduce so early after being born? To reproduce, they have to mature, and to be mature, we have to allow some time to them before they prefer to breed. We thus come to the Fibonacci rabbit problem, in which we make 2 changes. Number 1 is that the just born rabbits you got as a gift from your best friend is assumed to become fertile after 1 month of their birth. And number 2 is that they reproduce 1 month after being fertile, that is, their gestation period is 1 month. The other conditions are as before. We come to the solution now. On the first day of January, there was 1 pair of rabbit, that is 2 rabbits. They are babies, immature. They will take 1 month to mature and be fertile. So population on the first day or any other day of January is 1 pair, that is 2 rabbits. On February 1st, the pair is mature enough and they mate and will reproduce. That would take 1 month time. So in February, we still have 1 pair, that is 2 rabbits, because we have to allow time for gestation. After 1 month, that is on the first day of March, the pair reproduces to generate another pair. So we have now 2 pairs, that is 4 rabbits. Let us also mention that of these two pairs, the parent pair is obviously mature to mate and reproduce the next month, but the babies take 1 month to mature and will not reproduce the next month. Come first day of April, the baby is now mature and will reproduce next month. And the parent pair reproduces another pair, and so we have now altogether 3 pairs. The parent who is already mature, a pair that is just mature, and the baby pair that is 3 twos are 6 rabbits. On 1st of May, we thus have 1 baby pair that matures on this May day and 2 mature pairs who generate 2 more pairs. So we have 5 pairs now, of which 2 are immature and 3 mature. That is altogether 5 twos are 10 rabbits. On the 1st day of June, we have 2 just mature pairs who would reproduce next month, and the 3 mature pairs give birth to 3 more. So we have 2 plus 3 into 2, that is 8 pairs. That is 8 twos are 16 rabbits. We are at a very crucial juncture. Let us check the series generated. I mean the number of pairs of rabbits each month. And this is it. In January 1, in February 1, and in March it is 2. And 2 is 1 plus 1. That is sum of the past 2 months. Then in April there are 3 pairs, and 3 is 2 plus 1. Again, the sum of the previous 2 numbers. Let us check the number of pairs in May. It is 5, and again we see that 5 is the sum of 3 plus 2, which are the populations of the previous 2 months. So what should we be getting in June? It should be the sum of the numbers we got in May, which is 5, plus the number we got in April, which is 3. And 5 plus 3 is 8, and the number is indeed 8. So the series is loud and clear, and we can look upon the February population, that is the second term, as the sum of 0 plus the January population, which is 1. We thus have got a series known as the Fibonacci series or sequence, which is let us extend the series, and we have what should the number be in December? Let us write the formula to get it, and later we will do it directly, writing all the numbers of the series up to December. You can see the formula for the nth term of the Fibonacci series. We note that December is the 12th month and January next is the 13th month, and so you can calculate the 12th and the 13th term. same follows from the Fibonacci series when we match the terms with the months. We thus have solved the brain-teasing question posed by Fibonacci, and in the process arrived at the celebrated Fibonacci series, a great achievement. Leaving mathematics, which often deals with unrealistic problems, let us come to reality. The model or the Fibonacci sequence does not represent a viable, biologically realistic model for predicting population of rabbits, since several features have been ignored, and further, the assumptions are ideal and not realistic. For instance, though the gestation period for rabbit is 31 days on the average, rabbits are fertile after 3 to 4 months after their birth. They produce on the average 5 kittens per litter, can have 3 to 4 litters annually, litter being the number of babies taking birth at a time. Also, nearly 50% of the rabbits die in the first month of their life, and only about 20% live a year after their birth due to disease, infection, environmental stress, and predators. We come to the conclusion, therefore, that though rabbits have prolific breeding ability, the population cannot be predicted using the Fibonacci series. It doesn't follow the Fibonacci series. Due to the Fibonacci's use of rabbits to establish his series, rabbits have become infamous, and one uses phrases like breeding like rabbits to insult others. In this context, let us recall that the gestation period of the multi-estrus bandicoots is just 12 days, that of hamsters is 16 days, while mouse has gestation period of 20 days. And clearly, these species are also prolific breeders. But it is the rabbits who earned a bad name. It is they who suffer the ignominy or disrepute because of the Fibonacci mathematical problem. The phrase breeding like rabbits was used by Pope Francis on 20th January 2015. The Pope Francis was born in Buenos Aires, Argentina, and was a chemist and worked as a technician in a food science laboratory, invoked rabbits to explain his views about the size of an average Catholic family. He said that Catholics do not need to breed like rabbits, and later he clarified that the real cause of poverty was economic injustice and not large families. The phrase breeding like rabbits was also used way back in 1943 by Winston Churchill, describing the Indians to breed like rabbits. In India, he is remembered as the person who caused the Bengal famine of 1943, which resulted in an estimated death of about 3 million people in the then Bengal. Winston Churchill is known for being an army officer and Prime Minister of the United Kingdom from 1940 to 1945, when he led the country to victory in the Second World War, and again from 1951 to 1955. He was against sending any relief to India during the Bengal famine of 1943, since, according to him, it would accomplish little to nothing considering the large population, because Indians breed like rabbits. Dr. Shashi Tharoor, Indian politician, prolific writer and former international diplomat, in his book Inglorious Empire, points this out and argues that Churchill, though popular in the Western world as a victorious wartime leader and a protector of freedom and democracy, is not actually an apostle of freedom and democracy. Long live the rabbits!